Welcome back. This is a review for Unit 5 in Accelerated Algebra 2, and in this unit we're going to talk about radical expressions, functions, and equations. And so let's start off with Lesson 10, Radical Expressions and Exponents. For this one, you just want to simplify the radical expression by sort of simplifying all of the individual terms into their smallest power, right? And then you want to remember how a to the b divided by c power is also equal to the c root of a to the b power. Now lesson 11 was radical equations, and you want to do this, you're just going to do the reversal of order of operations in order to solve it, and then you're going to solve it like a quadratic equation, and then you're going to plug in all of the numbers back to find extraneous solutions. For lesson 12, we're doing this is for radical functions. You want to remember the set builder notation, which I have on the screen, and you want to remember the parent function, or the original function of a radical function, which is f of x is equal to negative a r squared root of negative b times x minus h plus k. Now I don't have on here, but there are two parent functions you have to remember, and that is f of x is equal to the square root of x, or f of x is equal to the cube root of x. So this is everything on here. And so lesson 13, we're going to be simplifying rational expressions. You first want to find the restrictions, and then you want to factor out each individual expression before you actually simplify it. For the division, you want to find the restrictions before you convert the second term into a reciprocal, and then you want to find it afterwards too. For multiplying, you want to cross multiply and then simplify it. So same thing with division. And for except for the fact that you have restrictions, right, on the reciprocals. And for adding and subtracting, you want to find an LCD before you do that. For lesson 14, we learned irrational expressions and inequalities. In equations, you want to find the restrictions, and then you want to set both sides equal by multiplying both sides by the LCD, and then you want to solve for x and find any extraneous solutions. And in inequalities, if you're using equal, greater than, equal to, less than, or equal to, you want to use you want to set the numerator to 0 in order to find all the zeros for that, and they're all going to be closed circles, while the denominators will be equal to open circles if you set that to 0. Right? But if they were actually less than or greater than, then they'd both be open circles. And then we're going to plug points down onto a line, and we're going to check for the solutions and then enter the notation. Now lesson 15 was rate of change, where it describes the same time, or the total time, so in order to solve at the same time, it's distance over the of the speed of yourself, or whatever it is. In addition, with the force, this is going with something, right? And that's going to be equal to the distance of something of yourself minus the force of that something that's going one direction only. And so for the total time, you just want to add those together and not do the total time. You're just going to solve that. And for lesson 16, we're going to be doing rational functions. For these ones, it's f of x is equal to a divided by x over x minus h plus k. You want to remember the vertical asymptotes and horizontal asymptotes. The vertical asymptote is x equals h, while the horizontal one is actually y is equal to k. Right, you also want to remember the parent function, which is f of x. So next you have f of x is equal to the p of x divided by the q of x. And so if you don't have a first you want to find out the zeros for the p of x, and that's if you set the p of x to 0. And then you want to find the vertical asymptote, which is q of x is equal to 0. You want to set that to 0 and solve for that. Then you want to find the horizontal asymptote, which is if the degree of p of x is equal to q of x, then you have the leading of the coefficients of both. You're going to find the quotient for both of those. But if it was less than q of x, then you're going to set y is equal to 0, right? And then if they do have a common factor, then that's when you find the whole. The whole is when you set whatever the common factor is to 0, and you solve for the y coordinate of the whole before the graph by plugging in. So here's a really bad drawing. You have two vertical asymptotes, and this one you only have one. And that's all. Please share this to other people, and if you haven't already, please subscribe. And thanks for watching.